Assalamu alaikum students. Today this is our second lecture. So in first lecture we discussed the introduction to physics, in which we studied what is physics, how physics is important for us for our daily life and for the development of our society. And then we discuss the branches of the physics. In today's lecture we cover two topics. The first one is physical quantities. The second topic is international system of units. So in this lecture, what we covered: what do you mean by physical quantities, what are the types of the physical quantities, and then what is system international units or SI units, what are the base and derived units, and on the last of this lecture we will solve a quick quiz which is given in your textbook on page number 7. So let's start. The first thing is, what are physical quantities? The definition of physical quantities are: all measurable quantities are called physical quantities. Remember, measurable quantities which we can measure, like we can measure a length in meters, in kilometers. Let's suppose we say that the length of this paper sheet is, let's suppose, 11 inches. We can measure length in inches. We can measure in different units. We will discuss later on. Similarly, we can measure the mass of the body. We can measure the time, temperature, and there are a lot of other physical quantities we can measure, of course, by using some suitable instrument. So to measure a quantity we required two major things. The first is its numerical magnitude, that how much quantity is, and then its unit. It qualifies the quantity. It qualifies the quantity that for example, let's we say the length is 3 meters. This small m is for meters. This small m is for meters. So you see, this 3 is a numerical magnitude, and it tells about the quantity, that how much this quantity is, how much the length is. The length is 3, and this meter is its unit. It shows measuring quantity is length. So we can say that the unit basically qualifies the quantity, that which quantity is to be measured. Similarly, a grocer says that each bag contains 6 kg of sugar. Now when he says 6 kg, 6 is the numerical magnitude, that how much sugar is in the bag, and kg qualifies that it is a mass. We are measuring some mass. So the unit shows which quantity is to be measured. So similarly, physical quantities are divided into two types. The first is the base quantities, and the other is derived quantities. Now what are the base quantities? Base quantities are the quantities on the basis of which other quantities are expressed. Means those quantities which does not depend on any other quantity, they are independent quantities and they are defined by themselves. Means we cannot define these quantities in terms of some other quantities. So total there are 7 quantities, and these are the length, mass, time, electric current, temperature, intensity of light, and amount of the substance. We will discuss all these quantities later in later chapters and in later lectures as well. So there are 7 quantities which we call are base quantities. Remember this thing. Now what are derived quantities? As the name suggests, those quantities which are derived from the base quantities. by combining base quantities, by multiplying or by dividing two or more base quantities, we get a derived quantity. So those quantities that are expressed in term of base quantities are called derived quantities. Theoretically, there are infinite in number, means we can make many derived quantities. However, they are not infinite. There are limited derived quantities, but theoretically we can say they are infinite in number. Examples: there are a lot of examples of the derived quantities, like area. Area is a derived quantity which is derived from the length. Similarly, volume, speed, power, energy, and there are a lot of other derived quantities we will discuss later on. These are all called derived quantities, which are derived from the base quantities. You will see later in this lecture that area, volume, speed, power, energy, these all are, and there are many other derived quantities which are derived from the which can be made by using base quantities. So now, a very important thing, the international system of units. As you see in this slide, we see to measure a quantity, to measure a physical quantity, we required a numerical magnitude and a unit. Now, unit is very important. If we do not have a unit, we cannot qualify which quantity is to be measured. For example, I say 3. What is 3? If we are not using a unit with it, we cannot know what we are measuring. Let's suppose I say 3 meter. Now it qualifies that 3 is the magnitude and meter is the length. So 3 meter means 3 meters length. So a worldwide system of measurement is known as international system of units. Remember, this is very important. Worldwide. This is worldwide system of measurement, because now we know that our world become a global village. So what we measure, for example, we are measuring mass. So measuring a mass in kgs, there are some local units, like we can measure mass in pounds as well. In British system, mass is measured in pounds. We measured in ounces. We measured in some other quantities. So, but there should be a worldwide system. That is why SI units are to be made. So a unit is a unique name that we assign to measure the required quantity. For example, like we discussed earlier, that meter is a unit to measure the length. Similarly, kilogram is unit for mass and Kelvin is for temperature. Why we need these units? Why we need a system, worldwide system of measurements? Why we need? So with the development in the field of science and technology, their need of commonly acceptable units was seriously felt all over the world, particularly to exchange the physical and technical information. So it is the requirement of the modern society to exchange our knowledge, to exchange our scientific facts, to exchange our technical information in a unique units. Means if we are using, like we are in Pakistan, so we are using units of mass like ounces, but in British they are using pounds. So it cannot be possible to exchange the knowledge in different units. So there must be a one unit. That is why the 11th General Conference on Weights and Measurement was held in Paris in 1960 and then in 1971 as well. So they adopted a worldwide system of measurement, which we called a system, international system of units, and commonly referred as SI. So SI is the abbreviation for system international or international system of units. Now these international system of units are divided into two types. The base units, of course, those units which describe base quantities are called base units. So each base quantity has its SI unit. For example, you see in this table, length. The symbol of the length is small l, and the unit of length is meter, and its symbol is m. So remember, this m represents the meter, while this m represents the mass. So when you are writing a symbol for the quantity, so this when you are writing this symbol for the quantity of mass, so we use m. But when we are using this m for the unit, this m means meters. So remember this difference. Don't confuse with these two m's with each other. The unit of the mass is kilograms kg. Basically the its unit is gram, but standard unit is kilogram. Similarly, time, it is seconds, and its symbol is small s. So small s is used for the seconds. Electric current, it is represented by I. This is small l. Remember, this is small l and this is capital I. So capital I is used for the symbol of electric current, and its unit is ampere, which is represented by capital A. Similarly, intensity of the light, it is represented by L, and the unit of intensity of light is candela, and its symbol of its unit is CD. Similarly, temperature is measured in kelvins, and its symbol is K. And amount of substance, the unit of amount of substance is mole, and its symbol is MOL. Don't worry about these units. When you progress into your studies of physics, we use these symbols for our calculations. So don't worry about what is candela, what is intensity of light. You all know in when you study further. So let's see what are the derived units. Now those units which are used to measure the derived quantities are called derived units. Now derived units are defined in terms of base units. Of course, like I said, that derived quantities are those quantities which are derived from the base quantities. Similarly, derived units are also derived from the base units, and they are obtained by multiplying or dividing one or more base units with each other. For example, the unit of area is meter square. So this m and this little 2 means square. So meter square, and the unit of a speed is meter per second. This is per second, and they are derived as follows. As you can see, the formula for the area is area equal to length into length. Length means length into width, but width is also a length. So we can say unit of area is meter square. How it become meter square? The unit of a length is meter. As we see in previous lecture, the unit of the length is meter. That is why I write the unit of the length is meter. Similarly, the unit of the length again meter, and meter is meter square. So in this case, the unit of area is obtained by multiplying the unit of a length with other length. Similarly, you see the unit of the formula for the calculating speed is distance divided by time. Don't worry about how these formulas are come from, where it come from. You will study further on in chapter 2. So just focus on the units. So unit of the speed is meter per second, and distance is measured in length. Distance is a length between 2 points. That is why the unit of the distance is also a meter, while time, the unit of a time, you can see in this table, the unit of a time is second. So that is why the unit of a time is second. So meter divided by second is meter per second. So in this case, unit of a speed is obtained by dividing unit of a length with unit of a time. So remember, first of all we look at the formula, and then we see what type of base quantities are used, and then we put the unit of these base quantities, and we can get a derived unit. So this table shows some derived units with their some derived quantities with their units. Just like we discussed in previous slide, that speed, it is meter per second and its symbol is meter per second. This -1 is per second. Okay. Similarly, the unit of acceleration is meter per second, or we can say meter per second square. Like volume has a unit meter cube, force has a unit Newton, and this Newton comes from kilogram meter per second. It means mass, length and time square. So mass, length and time are the base quantities used in this derived quantity, which is force. Similarly, the unit for the pressure is Pascal and it is Newton per meter square. Density is kilogram cubic meter, and similarly the unit of a charge is Coulomb, which is ampere second. There are a lot of other derived quantities, but these are the some of the examples that are given in your book. These are some derived quantities. Of course, when we study chapter number 4, 5, 6 and 7, we see other derived quantities like work, power, pressure, volume, density. We see all these units again and again. Okay, now let's move towards the quick quiz, the solution of the quick quiz, which is on page number 7. The first question is how you can differentiate between the base and derived quantities. We already discussed what are the base quantities, what are the derived quantities, how many number are there, how many base quantities are there and how many derived quantities are there, and what are the base quantities and derived quantities with examples. So you can write this answer for the quick quiz of page number 7. We already discussed all these things in this lecture. So next question is identify the base quantities in the following. Now remember, we need to identify the base quantities only. So speed is defined as distance divided by time. So distance covered divided by time. So distance is a length, because distance is the length between 2 points. Remember, distance is length between 2 points. So distance is a length, and time is already a base quantity. So the base quantities in the speed is length and time. Similarly, area. Now the area, the formula of not volume here. This is let me correct. Sorry. Let be. Okay. This is not volume. This is area. Okay. This is area. Okay. Now area is defined as length into width. Now length is a base quantity, width is also a length, so it is also a base quantity. So from above equation we see volume is a derived quantity and it is obtained from length and width. Now force. The formula for the force is mass into acceleration, and acceleration is defined as distance divided by time square. Don't worry how it when you study chapter number 3 and 4, you come to know that how these formulas are derived. So just remember, right now just remember that acceleration is distance divided by time square. Mass is already a base quantity, but acceleration is not base, so acceleration when acceleration is converted into base quantities, it will be distance divided by time square. Now we come to know from this equation that force has three base quantities. Force has three base quantities, which are mass, distance or a length, and time. Similarly, distance. So distance is already a base quantity, so we do not need to find any base quantity in there. The last question is identify the following as a base or derived quantities. So you can refer to these tables for the this this table is for derived quantities and this table is for base quantities. So density, it is a derived quantity, as you see in the table, like here this density is a derived quantity, so it is classified as derived quantity. You can refer this table later on. So force is also a derived quantity, speed is also derived, volume is derived, while base quantities are mass, time, length and temperature. The easiest way to remember what are the base quantities and derived quantities, so just remember only 7 base quantities. These 7 base quantities, when you remember these 7 base quantities, you don't remember derived quantity. You don't need to remember these are derived quantities, because other than these 7 are all the derived quantities. So I hope you understand what are the derived base and derived units, derived quantities, and what are physical quantities, and what is system international units. Thank you.